Dr. Memari with new experiment. The experiment for today is reduction of ketone using sodium borohydride. Sodium borohydride is a reducing agent that can reduce ketone to secondary alcohol and aldehyde to primary alcohol. For carboxylic acid derivatives, we do need stronger reducing agent, and that would be lithium aluminum hydride. The purpose of this reaction is to learn about the reduction reaction, as well as monitoring this reaction using IR spectroscopy. So our reactant is a ketone, has a specific peak at the 1700 for the IR spectrum, which after reduction, that peak is going to disappear on the product, and you will see a peak at the 3300. For more details about the chemical reactions and the purpose, please make sure to watch the pre-lab discussions for this experiment. So I'm just going to start the experiment here, following the procedure with the reduction of the fluoronone. Fluoronone is a yellow compound, is a bright yellow compound. We are measuring, following the procedure, we are measuring 1.5 gram of the fluoronone. Tear the mass of the vein paper and add enough to make it 1.5 grams. Fluoronone, as I said, and you could see, is a yellow color. The product of the fluoronone, which is the secondary alcohol, is going to be white color. So completion of this reaction is evident by changing color. When the yellow color disappears and the white color appears, or when you see that the yellow color disappears completely, that means the reaction is done. We will confirm completion of the reaction by using IR and the melting point of the product, but the at least the primary indication of this reaction or completion of the reaction is the fact that it's going to change color. Going to take a picture also for the record. Okay. So we have the mass of the fluoronone. We transfer that into a Erlenmeyer flask. The size of the flask, it shouldn't matter much, but I'm using the 125 for the volume of the solvent that is given. It's good. And we are going to measure 0.2 grams of the sodium borohydride as a reducing agent. Sodium borohydride is the excess compound. Is this reaction is going to be destroyed later on. But if the sodium borohydride 0.2 gram is not enough, but that means that the yellow color is not going to disappear completely. You can add another 0.1 later on. If it works, it works. Sometimes I ask the students to get 0.3 gram to begin with to save time. Other times we start with 0.2 and then we add another 0.1 as needed. So I kind of went in between now, so I'm adding 0.286 grams this time. .286 grams of the sodium borohydride. To this reaction, to the fluoronone, we are going to add the methanol, and we add the reducing agent to the solution of the fluoronone. Then want to mix two solids together. 30 milliliters of the ethanol, fluoronone, dissolved, and almost dissolved. Now we are going to add the reducing agent. And mix it. This reaction is going to take a while, and it requires a constant stirring. It doesn't require heat, but it does require constant stirring. So I'm going to use a magnetic stir bar and place it on the hot plate and turn on just the stirrer for it and wait for 30 minutes for this reaction to complete. So as the reaction, you see that right now we have solution, the yellow color solution. The product is white color and it's also insoluble. So you will see that a white precipitate is going to form. If the yellow color disappears completely, we can stop the reaction. If it's 30 minutes and the yellow color has not disappeared yet, we add more of the sodium borohydride to make sure that the reaction is complete. So since it's going to take about 30 minutes, we are going to pause the video at this point and come back in 30 minutes to check the color of the product.